Dear students, welcome to today's class. In the previous classes, I explained about sets, various types of sets, properties of sets, and the relations, various types of relations and properties, all those things we discussed. Now, if you go further, after relations, we got a very important chapter, that is functions. Okay, right. So, let us learn what is a function today. Okay, now, right. To make a function, generally in our day-to-day life, we will do different types of functions. Birthday function, anniversary function, school day function, sports day function, all those things we do it. So, generally what happens, a function means there will be a two group of persons will be there. One is the person who invites the guest, and another group is the person who are going to attend the function. Okay, now definitely there will be two sets will be there. To make a function, there will be a two group of sets should be there. So if it is you are doing anything in your home, that cannot be called as a function. If you are inviting somebody others, so for example, if you are doing a birthday celebration, so you yourself you are doing in your home, we cannot call it as a celebration. We cannot call it as a function. If you are inviting others, that means another group of persons, then we call them as a function, birthday function, like that we call it. That's why, so to make a function, there should be two persons should be there, two non-empty sets should be there. So if it is an empty sets, you cannot do anything. Okay, now, right. So A and B be two non-empty sets. First of all, there should be two non-empty sets. And what is a function? Function is a rule that assigns or maps, gives, attach, whatever word you can use, every element of A. That means in the set A, whatever may be the first set you are taking, every element of A to a unique element of B. Here the two words are very important. The first one is every element of A. Second one is unique element of B. That means what? Every element of A, in the set A, there should not be any element which does not have attachment with B. See here, 1 is mapped onto B, 2 is mapped onto B, or attached or assigned, or whatever may be the linked, whatever may be you call it as. 3 is linked to C, 3 is attached to C, 4 is attached to D. Understand this? 4 is attached to D. So this is called a, then we say that there happens a function from A to B. Okay. I am writing one another two sets here. Let us check whether that function happened from A to B. For example, here set C and set D. So I am taking here 1, 2, 1, 3, 4. Here X, Y, Z, W, L. 1 is mapped onto X, 1 is mapped onto or assigned to Y, 3 is mapped onto Z, 4 is mapped onto again Z. Now say that, is there any function happened from C to D? Let us check. Let us see the first condition. Every element of A, okay, every element S, all in the set of C, all the three elements, 1, 3, 4, should be attached to or linked to unique element of B. One and only one element of B. If you observe here, the element 1 is attached to X and Y. The element 1 is attached to X and Y. Okay? 1 is attached to X and 1 is attached to Y. Okay, now? Right. That's why which condition fails? Here the second condition failed. What is that? Every element of A, yes, every element of C is attached to two elements. It is not unique. That's why it is not a function. It is not a function. Okay, now, but you may ask one doubt here. Sir, here 1 is attached to B, yes, 1 is attached to B, 1 is mapped onto B, 1 is assigned to B, yes. That is over. 2 is mapped onto B, yes, right. 3 is mapped onto C, 4 is mapped onto D. Understand? So such a type of one mathematical structure. This mathematical structure is called a function from A to B. Understand? So in mathematics generally, whatever may be thing happen, we will give in terms of its notation. Here, what is the notation means? What is the function? Name of the function? We will take small letters, small g, small f, small h. What that such type of letters is, but maybe sometimes capital letters also we can take. So here function is happened from which? Here they are the invitees. These are the guest. So they are the invitees to guest. Okay, A to B. Understand? So this is a mathematical notation to represent a function from A to B. So from this, what can you say? To happen a function, there should be two non-empty sets. Sometimes both sets also will be equal. So that we call it as a, I will discuss in the another way. So both sets will be same. But in general, there should be two different sets, A and B. Okay now. Every element of A, every element, whatever may be the set contains the first element, first set, every element of A should be attached to or mapped onto another element of B. Okay now. So from this we can say that a so what is from this definition of function? So it is just like a machine. It is just like a machine. It is just like a machine. Whatever may be the input you give. Okay, so it is the function f of x. I will tell you what is the notation function. So what is the function input you are getting? What your output you are getting? You are f of x. The output is f of x you are getting. Okay, so it is a input output machine. We can call it as a function is an input. So you are giving 1, you are getting b. You are giving 2 to this function, you are getting b. You are getting input is 3, then the output is c. Input is 4, the output is d. Understand? So it is just like a input output machine function. Okay now we are going to see what is this f of x? What is this f of x? What is the rule of the function? That we are going to discuss now. Okay now. Dear students, now we are going to see the rule of a function, or sometimes we call it as a formula of a function. Formula of a function, rule or formula of a function. Let us see here. There are two non-empty sets. It is also a set of natural numbers, and another set is also natural numbers. Here also I have taken both the sets are natural numbers. As clearly every element 1, 2, 3, 4, 5, 6, so on, it is attached to the elements in the another set B. Observe here, 1 is mapped onto 2 or assigned to 2. 2 is mapped onto 5. 3 is mapped onto 10. 4 is mapped onto 7. Is there anything pattern you are observing? So in the sequence and series we can get any pattern. 1, 2, 2, 5, 3, 10, 4, 17. Like that if you go on, 5 will be mapped onto any elements. 5 will be mapped onto any element. So I can say that it is 26. How can you say, sir? If you observe, if your element is 1, it is mapped onto 1 square plus 1. If your element is 2, 2 square plus 1. If your element is 3, 3 square plus 1. If your element is 5, 5 square plus 1. That means, in general, if your element is x in the first set, then you are what will be, for which number you are attaching. Afterwards I will tell what is image and what is pre-image, I will tell. So with what number? 5, 5 square plus 1, this is a 5 square plus 1. This is 17, this is equal to 4 square plus 1. This is a 10, this is a 3 square plus 1. So this is a 2, this is a 2 square plus 1. This is equal to 1 square plus 1. So that is equal to 1 square plus 1. If it is 2, 2 square plus 1. If it is a 3, 3 square plus 1. If it is a 5, 5 square plus 1. Generalize this. If your element is x, then you are attaching to x square plus 1. So this is called rule of the function or formula of the function or condition of the function. Understand this? Condition. For this, from this what can you say? For example, if you are given a number 10, what will be your image? What is your image? 10 square plus 1, 101 will be the, you have to attach according to this rule, you have to attach the number 10 to the number 101. Now let us see here, from this anybody can say, from this you can say anybody can say. So if it is a 1, you are attaching, this is a 2 into 1 plus 1. If it is a 2, you can say 2 into 2 plus 1. If it is a 3, here 7 is a 2 into 3 plus 1. If it is 4, it is attached 2 into 4 plus 1. From this, what can you say? If your element is x, so this is equal to 2 into x plus 1. 2 into x plus 1. That means, from this, if it is a 5, then is equal to 2 into 5 plus 1. 2 5s are 10, 10 plus 1, 11. 2 5s are 10, 10 plus 1, 11. Okay, now. If your element is a 8, so this is a 2 into 8 plus 1. 2 8s are 16, 16 plus 1, 17. So this 2x plus 1, this 2x plus 1 is called a rule or formula of that function. So this is denoted by, since the function name is f, this is denoted by f of x is equal to x square plus 1. Since the function name is g, this is denoted by g of x. G of x is equal to 2x plus 1. Okay, now, sir, all functions should have, must and should have rule, formula, definition. You should have. No, no need, no need. For this function, if at all, if it is there, that can be represented as f of x is equal to x square plus 5. Here, there is a rule is following. That's why g of x is equal to 2x plus y. So f of x. So there are. So in our course time, so we will come across too many times. So f of x is equal to x square plus 1 by x plus 1. So g of x is equal to mod x. H of x is equal to sine of e power x. So these are all formulae or definition like that only here can be. Sir, there are some functions are there which does not have any rule. For example, take this is a set and set B, A, B. Here 1, 2, 3, 4. 1, 2, 3, 4. 1 is attached to 2, 2 is 2. 3 is again 1, 4 is attached to 3. So if you observe here, there is no rule, nothing here. There is no rule, nothing. So if you want to get any formula, you cannot get any formula. That's why then can we say that it is not a function? No, no, no. Yes, it is also a function. H from A to B is also a function. If at all any rule is there, we will represent this. So from this, whenever it is given that in a problem, if it is given that f from A to B is defined as f of x is equal to x square minus 2x plus 5. From this, what can you say that? From the immediately, what is the idea what you have to get? So if your element is x, so the formula is defined as x square minus 2x plus 5. This is a general formula. This is a general mechanism. So from that, you can find out the images of any element which belongs to the domain. Okay. So now we are going to see the very, very fundamental definitions of domain, codomain, range of a function. Okay. Now, so in that we will define what is a image and a pre-image of a element. Okay. Now, so let us continue our class. Dear students, now we are going to discuss about what is image and the pre-image or inverse image of an element of a function. Okay, now see here, first I have already told that to make a function there should be two non-empty sets. So let us see that the first set containing the elements 1, 2, 3, 4, 5. The second set contains the elements x, y, z, w, l, m, n. Okay, right. Yes, clearly it is there is a function happens between A and B as per the definition. So once again I will revise the definition. What is the definition? Every element of A, 1, 2, 3, 4, 5, S, arrows started from every element, arrow started, S, all arrows started, right, is mapped onto or attached to unique element of B. That means one and only one element. One is attached to, mapped onto or assigned to only one element, that is y. That's all. Forget about that. 2 is mapped onto y, one element only. 3 is mapped onto z. 4 is mapped onto w. 5 is mapped onto w. So here there are two words are coming, that is the image and the pre-image. Generally image means what? So whenever we see generally in the morning as we wake up, immediately what we see? We see our image in our mirror. Okay na? So this is our face and we will get the image. Okay na? Same it happens. So here our mirror is there, no? That is our function here. The mirror is a function. The elements, those which belongs to our parts are A, and whatever appears in the mirror, that is images. So clearly Y is the image of 1, Y is the image of 2, Z is the image of 3, W is the image of 4, W is the image of 5. Understand? So that is Y is the image of 1. Y is the image of 1. So if you want to read in a reverse way, for example, in our number system we will read like that. So 2 is a factor of 4. 2 is a factor of 4. So you read it in a reverse way. 4 is a multiple of 2. 4 is a multiple of 2. 2 is a factor of 4. In a reverse way, you read as a 4 is a multiple of 2. So here also, if you read in a reverse way if you read it, that means Y is the image of 1. If you read it as 1 is the pre-image of Y. That is 1 is the pre-image of Y. 2 is the pre-image of Y. 3 is the pre-image. Pre means what? Start, first. Pre means what? Before. Pre-final, before. Image, before. That means 3 is the pre-image of Z. 4 is the pre-image of 4, W. 5 is the pre-image of W. In the reverse way, Y is the image of 1. Y is the image of 2. 2 is the pre-image of Y. So this is the image, pre-image. Sometimes pre-image also call it as a inverse image. That is 1 is the inverse image of Y, 2 is the inverse image of Y. Understand? Now coming to the notations. A very, very important notation we are going to see here. Very, very important notation. Actually, this is the second notation. What is the first notation in functions we got? So this is the first function. That is F from A to B. This is the first notation. Function name is F, A and B are two sets, arrow mark, 2 dots. So this is the first notation in the function. Now we are going to see the second notation. What the second notation is? Same. Here 2 sets are there, A and B. Your function name is F. If your element is X, its image is denoted by F of X. Sir, why sir F? So function name is F. Function name is, that is a brand name. It is a brand name. For example, if you take a pen, so all pens are there. So when you are first of all it is a pen. Afterwards they will write a brand name. Tata product, Ambani product, Reliance product. That is also brand name. So here also F is a brand name. So here all chappals will be there. So if it is manufactured in Tata company, then it is called a Tata or Bata or Karora, whatever may be that. Understand? It is a brand name, F of X. If it is a brand is G of X. If your brand name is H of X. Or sir, all laptop computers are manufactured in only one company only, one place only. But when you write a brand name, it will become HP, whatever may be the different Lenovo, HP, Dell companies will be there. Like that, this is also company name, F, G, H, like that will come. So if your product is just a laptop company only, all laptops are same. But if your brand name is F, then you are getting F of X, Lenovo. Mobile phones are also like that. Okay, all mobiles are manufactured in only one company, only one place only. But when you put a brand name, then it will become different brands we will get. Okay, Oppo, Vivo, different brands we will tell. Okay, now like that. It is also brand name. So if your X is there, then your brand name is F, therefore your image is F of X. Okay, so like that. So if your element is X1, its image is F of X1. If your element is X2, your image is F of X2. Like that it is going on. Understand? It is like that going on. Understand? Right. So the second notation that we are getting in our function chapter is x, then f of x. Always remember that. Always remember that x belongs to a. F from a to b is a function. X belongs to a. Then f of x belongs to b. Where will be f of x? It will be in the b. If x belongs to a, in the bracket, if it is x, here f of x. If it is a function is from c to d. If it is a y, then g of y belongs to d. If y belongs to c, then g of y, g of y will be where it will be there? It will be in the set d. Here what is the function name? G. That's why g of y. Okay now? So I hope that you understand these notations, both the notations f from a to b. So f of x, what is that? F of x. So in the previous rule we are taking that here f of x will be different in different problems depending upon the rule definition that defined the person who created that problem. Okay now? So after this we are going to learn what is a domain, codomain, range of very important topics. Okay, so let us start that. Dear students, now we are going to discuss a very important topic, that is domain, codomain and range of a function. So very easy to learn. Okay, fundamental definition very easy. Let f is a function from a to b. A contains the elements 1, 2, 3, 4, 5 and set b contains the elements 6, 7, 8, 9, 10, 11, 12, 13, 14 as f is clearly a function from a to b. Why? Because every element of A is mapped onto a unique element of B. Okay now the definition of domain is the set of all the elements. So for example, if you conduct any function in our home, conduct a function in any home. So what I told, first a group of persons who invites the function, they will be there. Okay now, what the second one? There will be a second set of persons who are the guest invitees will be there. Okay now, right. So in the function generally all invitees, all guests, they were not actually participate in the function. Just they will come and sit side by and they will show the magic. Remaining some guests will be there, they are actually participated in the function. Okay now, some guests will be actually participated. So actually those three set of peoples will be there. One set is those who invite the function. Second set is guest, but in the guest only some guests will be very active, some very active. They will sing songs and they will do entertainments, they will do Gana, Bajana, Hangama, like that. So here also the same thing happens. Here the set of people, 5 members, they are organizing a function, they are invited the guest. Okay, one family is there, father, mother and their 2 children and their grandfather, they invited. So these are all guests are there. Guests, who are the guests? 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 guests are there. But in that 7, 8, 10, 11, they are actually participated in the function. So they are singing songs, they are doing hangama, whatever may be that. So remaining all just they participated in the function. So here the set of elements which belongs to A, all the elements which belongs to A, this is called domain of the set A. Understand? It is called domain of the set A. 1, 2, 3, 4, 5. All 1, 2, 3, 4, 5. Next codomain means all the guests. 6, 7, 8, 9, 6, 7, 8, 9, 10, 11, 12, 13, 14, all the guests. They are our codomain. In the codomain, in the guest, those who are actually participating, 7, 8, 10, 11, they are very active. So they started hangama. So this is called range of the function. Okay na? So it is denoted by f of A. F of A. Why? Because if just now I explained. If an element is x, your image is denoted by f of x. Of course, since the function name is, brand name is f, that's why f of x. If your brand name is G of x. Okay na? So if your brand is Lenovo of x. If your brand is some HP of x. So if your brand is Oppo of x. That's all. all are equal. All cell phones are equal. Because of the brand, it will come. Brand come. That's all. Here also the same thing happens. Understand? So range of F means, that's all. Images. Images. What are they? 7, 8, 10, 11. What are they? They are the images of the elements of A. That's why this is called range of A. That means 7, 8, 10, 11. What are they? They are the images of the elements of A. That's why this is called F of A, not one element. If it is one element, F of X. But 7, 8, 10, 11, so it's a group, no? That's why we call it as F of A. Range means the set of all the elements of images of the elements of A, right? From this one, a very, very important conclusion we can get. So the first conclusion is domain cannot be the subset of codomain, and codomain cannot may be subset, may not be subset. We cannot sure. But one thing is sure. One thing is sure. What is that? What is one thing? Range is there, no? 7, 8, 10, 11. That is surely a subset of codomain. That means it is codomain. It is domain, range. That is, range is the subset of codomain. Subset of codomain. Codomain. I will write here one more thing. What is that? Range is subset or equal to codomain. Can I say subset or equal to? Yes, sometimes. Sometimes if it is 6 is not there, 9 is not there, 10, so all the whatever may be the 4 guests, all 4 are enjoying. All are 4 are enjoying. What are all guests who are they came, they are enjoying like anything. So here codomain, range, both are sometimes equal. Understand or not? So it is sure. What is the sure? Codomain, range is the subset or equal to codomain, but it is not sure that domain is a subset of codomain, codomain is a subset of domain. That is not sure. That depends upon the problem it's given. Understand this? So this is about domain, codomain, range of a function. Okay. I hope that you understand this concept. Dear students, I hope that you enjoyed today's class. So about the function and domain, codomain of a function, image, pre-image and the inverse image of a function, rule or formula of a function. Okay. I hope that you enjoyed today's class. In the next class, we will discuss some more problems, that how to find out the domain of a function and the range of a function. Up to that I will explain. Afterwards I will go for types of functions, different things I will discuss. First, whatever may be the discussed topics today is there. So tomorrow's class I am going to discuss some problems related to domain, codomain, range. Okay na? So until then, all the best.